Dear farmers, integrated nutrient management is a crucial approach that ensures the optimal fulfillment of nutritional elements in crops, maintaining a delicate balance. Let's discuss the benefits of integrated nutrient management. 1. Increased soil fertility and crop yields. 2. Reduced cost of fertilizer management for crops. 3. Conservation of soil through the use of natural nutrient resources like organic manures, biofertilizers, and green manure. In this video, our aim is to explain the practices of integrated nutrient management for paddy potato wheat and paddy potato maize rotations, as proposed by Punjab Agricultural University, Ludhiana. Let's delve into the details and explore these effective techniques together. In the paddy potato wheat rotation, it is recommended to sow a short duration variety of paddy, such as PR 126, in the middle of June. This allows the field to be available by mid-September for sowing a short duration variety of potato, such as Kufri Chandramukhi. The potato crop is then harvested after 12 months, making way for the sowing of a late sown variety of wheat, such as PBW 752 or PBW 658. In the paddy potato maize rotation, it is advisable to sow a short duration variety of paddy, such as PR 126, by mid-June, which allows for its harvest by mid-September. Following this, sow a short duration variety of potato, such as Kufri Chandramukhi, by the end of September. After a period of 12 months, the potato crop can be harvested, making way for the sowing of any suitable spring maize variety, as displayed on the screen. The optimum sowing time for spring maize is between January 20th and February 25th. Now, let's discuss the 7 components of integrated nutrient management for these 2 crop rotations. The first component of INM is soil testing for balanced use of fertilizers. In order to collect soil sample for testing, scrap away the surface litter and make a V-shaped cut with a spade or kerpa to the depth of 6 inches. Collect about 1 inch thick uniform slice of soil from one side of the cut. Similarly, collect samples from 7 to 8 places in the field. Pour the samples into a clean bucket/tray or cloth to mix it thoroughly and then transfer approximately ½ kilogram of soil into a cloth bag. Then label this bag with information such as field number, name of the farmer, address, date of sampling, etc. Soil samples, however, should be collected after harvesting the crops. You can get the soil sample tested from Punjab Agricultural University, or Krishi Vigyan Kendra of your district, or Soil and Water Test Lab of State Department of Agriculture, once in every 3 years. Use of organic manures is the second component of integrated nutrient management. Application of 6 tons of farmyard manure or press mud in paddy crop can save 35 kg or 55 kg of urea per acre, respectively. If 6 tons of press mud were used in the paddy crop, then apply only 75 kg of urea in 2 equal installments. Additionally, drill 75 kg of single superphosphate, SSP, or 28 kg of diammonium phosphate, DAP, per acre as a basal dose for the succeeding wheat crop. Using 2.5 kg of poultry manure or 2.4 kg of dried gobar gas plant slurry can save 55 kg or 35 kg of urea per acre, respectively. If any of the aforementioned manures were applied to the paddy crop, it is recommended to reduce the dose of nitrogen and phosphorus fertilizers by 25% and 50% respectively for the succeeding wheat crop. Therefore, for the wheat crop, use only 80 kg of urea and 75 kg of SSP or 28 kg of DAP per acre. Similarly, for the wheat crop, apply 4 tons per acre of rice husk ash or bagasse ash before the last plowing. Additionally, reduce the dose of phosphorus by half, using only 75 kg of SSP or 28 kg of DAP per acre. The application of 2 tons per acre of Pralicor can save 35 kg of urea in both paddy and wheat crops. For wheat or maize following potato, which received the recommended dose of farmyard manure, FYM, and no phosphorus, only half of the recommended nitrogen dose, which is 55 kg of urea per acre, needs to be applied. On the other hand, in spring maize, the application of 6 tons of good quality farmyard manure eliminates the need for macro and micronutrients that are recommended as a basal dose. Now, let's move on to the third component of integrated nutrient management, which is called green manures or legume crops. Sow sunhemp or daincha 20 kilograms or cowpea 12 kilograms seed per acre in first week of May. And bury 6 to 8 week-old crops, 1 day before transplanting paddy. Green manuring leads to a saving of 55 kilograms urea per acre and helps in addressing micronutrient deficiencies in rice crops. If leguminous crops were incorporated into the land before sowing wheat, it is recommended to apply only 80 kilograms of urea in 2 equal installments for the wheat crop. Now comes the fourth component of integrated nutrient management, that is incorporation of crop residues. The incorporation of paddy straw not only effectively controls annual weeds but also helps in nitrogen conservation. When paddy straw is burnt, it releases harmful gases such as carbon dioxide, carbon monoxide, methane, and nitric oxide into the environment. This leads to severe air pollution, which negatively impacts the health of humans and other living organisms. Additionally, the burning of 1 ton of paddy straw results in the loss of 400 kilograms of organic carbon, 5.5 kilograms of nitrogen, 2.3 kilograms of phosphorus, 25 kilograms of potassium, and 1.2 kilograms of sulfur. Use of biofertilizers is the fifth component of INM. Fellow farmers, the initial step in seed treatment involves applying the fungicide, followed by the insecticide. Biofertilizers, on the other hand, are applied as the final step in the seed treatment procedure. Biofertilizers can be applied in 3 ways, i.e., seed treatment, soil mixing, and seedling treatment. Dear farmers, half a kilogram of azospirillum is mixed with 100 liters of water and applied to the roots of paddy seedlings. This practice leads to an increase in crop yield by 3 to 4% per acre. The application of a 4 kilogram consortium per acre, mixed with the soil during potato sowing, results in a 4 to 5% increase in production and improves soil health. The application of a 500 gram consortium or a mixture of 250 grams each of Azotobacter and Streptomyces, mixed with 1 liter of water, increases the yield by 1 to 1.5% per acre. Sowing maize seeds by mixing them with a half kilogram of consortium increases the yield by 4 to 6%. The table provides the recommended doses of biofertilizers for paddy, potato, wheat, and maize crops. You can purchase these biofertilizers from Gate Number 1 or the Department of Microbiology at Punjab Agricultural University, Ludhiana. Alternatively, you can also visit the Krishi Vigyan Kendra in your district to obtain them. Sixth component of integrated nutrient management is balanced use of fertilizers, which includes doses, timing, and method of application. Soon after the soil test, you will get to know the amount of macro and micronutrients and organic carbon present in your soil. But for good integrated nutrient management in paddy potato wheat rotation and paddy potato maize rotation, you should keep in mind the following important instructions. For early maturing varieties of paddy, it is recommended to apply urea fertilizer in 3 equal splits. The first split should be applied 7 days after transplanting, followed by the second split at 21 days after transplanting, DAT. The final installment should be applied after 35 DAT. In the case of late-sown wheat, it is advised to apply urea fertilizer in 3 installments. At the time of sowing, 20 kilograms of urea should be applied per acre. This should be followed by 2 equal splits of 35 kilograms each, with the first split applied during the first irrigation and the second split during the second irrigation. However, for the wheat crop that follows a potato crop, it is recommended to use only half of the recommended dose of urea, which amounts to 55 kilograms per acre. In the potato crop, along with the application of 20 tons of farmyard manure or green manure per acre, it is advised to use 165 kilograms of urea. The urea should be split into 2 equal parts, with the first half applied at the time of sowing and the remaining half applied during the earthing up of the soil, which is typically done 25 to 30 days after sowing. In spring maize, it is recommended to use 110 kilograms of urea. 1/3 of the urea should be drilled at the time of sowing. The remaining urea should be split into 2 equal halves, with each half being top-dressed at the knee-high stage and the pre-tasseling stage of the crop. Dear farmers, it's important to note that a crop is not capable of consuming all the phosphorus available in the soil during its single life cycle. So, large amounts of phosphorus remain in the soil, hindering the uptake of zinc. Consequently, this leads to zinc deficiency in the crop. So, in the paddy potato wheat rotation, it is recommended to apply 25 kilograms of phosphorus, equivalent to 155 kilograms of SSP, at the time of sowing. This eliminates the need for additional phosphorus application in the succeeding crops of the rotation, namely wheat and paddy. Similarly, in the paddy potato maize rotation, phosphorus will be applied only to the potato crop, eliminating the need for its application to other crops in the rotation. Although the chances are low for the succeeding wheat or maize crop to show phosphorus deficiency symptoms after using 25 kilograms of phosphorus in the potato crop, however, if this situation occurs, it is recommended to use 12 kilograms of phosphorus per acre for the PMH7 variety of spring maize and 24 kilograms per acre for all other varieties of spring maize. Similarly, in such conditions, 25 kilograms per acre of phosphorus is recommended for wheat. Zinc, iron, and manganese are nutrients that should be applied selectively to soils that exhibit deficiencies in these elements. In the paddy potato wheat and paddy potato maize rotation, potassium fertilizer should be applied exclusively to the potato crop. It is recommended to use 40 kilograms of MOP, muriate of potash, per acre at the time of potato sowing. However, in other crops such as paddy, wheat, or maize, the application of 20 kilograms of MOP, muriate of potash, is recommended only if deficiency symptoms of potassium appear. If zinc deficiency appears in paddy or wheat crops, it is recommended to broadcast 16 kilograms of zinc sulfate monohydrate or 25 kilograms per acre of zinc sulfate heptahydrate to address the deficiency. Similarly, if spring maize shows symptoms of zinc deficiency, it is advised to use 6.5 kilograms of zinc sulfate monohydrate or 10 kilograms per acre of zinc sulfate heptahydrate at the time of sowing to address the deficiency. According to the soil test report, if the soil is found to be low in organic carbon, it is recommended to increase the dose of urea by 25% compared to the recommended amount. On the other hand, if the soil is high in organic carbon, it is advised to decrease the dose of urea by the same amount, 25%, as recommended. In addition to the phosphorus content of the soil, the organic carbon level also influences the quantity of phosphorus present in the soil. Use the recommended dose of phosphorus in all crops if the soil contains a medium amount of organic carbon. However, if the soil has medium to high levels of organic carbon and very high levels of phosphorus, or if both organic carbon and phosphorus are present in high quantities, then it is recommended to avoid applying additional phosphorus to that soil. And reduce the dose of phosphorus fertilizer by 25% if both of them are present in medium amounts in the soil. If the soil has high levels of organic carbon and medium levels of phosphorus, or vice versa, it is recommended to apply only half of the recommended dose of phosphorus to that soil. The seventh component of INM is the PAU leaf color chart, LCC, which measures the intensity of leaf color and is related to the nitrogen status of the plant. The LCC is an ideal tool for optimizing nitrogen use in rice, maize, and wheat crops. To use the LCC, randomly select 10 plants and compare the color panels of the chart with the greenness of the topmost fully developed leaves. It is important to observe the leaves under the shade of your body to ensure accurate color matching. The selected leaves should be free from any incidence of insect pests or diseases. This ensures that the color assessment is not influenced by any external factors and provides an accurate representation of the leaf's nitrogen status. If the greenness of 6 or more out of 10 leaves is lighter than the specific shades indicated on the LCC, it indicates a nitrogen deficiency. In such cases, the recommended dose of urea per acre should be applied to fulfill the nitrogen requirements of the crop. And if the color of 6 or more out of 10 leaves matches or is darker than the specified shades on the LCC, it indicates that the crop has sufficient nitrogen and there is no need to apply urea. The following table presents the recommended doses of urea corresponding to different shades on the leaf color chart, LCC. You can purchase the LCC from the bookshop located at gate number 1 of Punjab Agricultural University or from the Krishi Vigyan Kendra in your district. In conclusion, we hope that this video has provided you with valuable knowledge on integrated nutrient management in the context of paddy potato wheat and paddy potato maize rotation. By implementing these practices, you can enhance the fertility of your soil, improve crop yields, reduce fertilizer costs, conserve soil, and promote sustainable agriculture. Thank you for watching, and happy farming!